Hello students, we're going to be looking at Laboratory 3.7 resonance circuits. And we're going to have some familiar formulas like trying to figure out the X of L and X of C for our circuitry. We're going to build a series circuit that has both an inductor and a capacitor in there. Now inductors and capacitors have reactances. These reactances are forces that are going to be vertical. So we're looking at the triangle. We're looking at a voltage, current, or a impedance triangle. The X of C and X of L are impedances that oppose each other. So there are forces against each other, and the magnitude of the force is whichever one of those is larger. So we're going to build a circuit, and what we're trying to do at Resonate, we're trying to get X of L to equal X of C. They'll cancel each other out, and then we should see most of the magnitude of the signal on the resistor. Now there's a way to calculate the resonant frequency, and it's going to be 1 over 2 pi the square root of inductance times capacitance. I've written the numbers up here. We're using a we're going to be using a 100 millihenry inductor, or 0.1 Henry. We're going to use a 0.01 microfarad. So make sure put that on there. There we go. We're using a 0.01 microfarad, and when I do that, my resonant frequency comes out somewhere close to 5,000. 5,030 is what I have here. And then finally, we're going to look at some new ideas. We're going to look at Q, and Q is going to be the X of L, and it's going to be divided. The resistance is going to be divided into that. So RT. Now RT for this signal is going to be what the value of the sensing resistor is, which is 100 ohms, plus the resistance of the signal generator we're going to call 50 ohms, plus the resistance of the winding, which we're going to estimate at 50 ohms. It may be more than that. So you're going to add 50 ohms for the signal generator, and whatever your resistor reads, whether you're using 47 or 100, and plus the resistance of the winding. I just estimated at 200 ohms. So my Q comes out to be 15. And then I want to read what the bandwidth is. And the bandwidth is the width of the signal at about 71% from the beginning to the ending of the signal. So I'm trying to draw that down there at the bottom there, as you can see that. And what I'm trying to indicate there is that your bandwidth, you're going to come down 70% on your left side of the signal and go down 70% on your right side of the signal. And the distance between those two is going to be the bandwidth of the signal. In this case, we say the bandwidth is close to about 3. So my calculation experiment with this lab is somewhere between 250 to 350 is what you should come out to as far as a bandwidth. So let's take a look at the circuit. We are going to be looking at resonance circuit. So this is page 105 in your lab book. It's got instructions there. The instructions are pretty informative, so make sure you go through the instructions to look at that. And on 106, you're going to have some information to fill out. You can just take your components and read them. Now, I've seen some different labels on here, maybe in the schematic, but we're going to use a 0.01 microfarad, or 10 nanofarads is what it should say on the meter. Okay, so we're going to look at that. And then the RW, the resistance of the winding, or the actual ohmic value of this L. And that usually is somewhere between, in most cases, 70 to 100 ohms is what I've seen. Now this, make sure this capacitor is going to be 0.01 microfarad. We're calling the resistance of the winding here is somewhere around 70 ohms, I'm guessing. You can use a 100 ohm resistor if you don't have a 47 ohm. Internal resistance of the signal generator we are calling 50 ohms. And then there's a chart down here that you're going to fill out. You're going to look at the total resistance. You're going to look at your resonant frequency, which I calculated to be a little over 5,000. Your Q, your RS1 is just going to be the sensing resistor. And then we're going to look at the frequency of 1 and 2 together to calculate bandwidth. And then we're going to look at the voltage drop on the VC and the VL. So let's take a look at our signal here. Okay. Now I'm looking at my signal here. This is information that we're looking at, and it is reading the voltage that is on the inductor and capacitor together. Now here's my circuit. I've got my, if I look here, tilt that up, I've got a inductor at the top, capacitor, green capacitor in the middle, and my sensing resistor down here, which is 100 ohms. Let me zoom back a little bit so you can take a look at that. All right, so that's what I've got for setup. So it looks like this one over here is looking at the voltage on my components, and this is looking at the voltage on the resistor. My resonant frequency here, I calculated to be 5,000. Let's bring this up to 5,000. Now, one thing was what you're going to look at here is that I'm going to adjust my frequency. I'm just turning this knob back and forth, and we're going to adjust this until we get the highest magnitude there. So that looks like my highest, and it's around 45. So your actual, you're gonna maximize what that is and figure out what that is, and then we're gonna max that out. So there's some instructions there. I think it's step number 7 or 8 in your book, and it tells you what we're gonna do to figure this out. Is that I've got this thing set here, and this is for my bandwidth here. And my voltage here is, about 1 volt. So I'm going to increase and decrease my frequencies to figure out what the left side and right side of my bandwidth should be. And the way I'm going to see that is that when this number right here, get a pointer here, when this number on my voltage peak to peak reaches somewhere close to 0.707 or 707 millivolts, that's going to be one side of that sine wave. So I'm going to back it off a little bit, bring it up to 707. Takes a little finesse. So we're going to call that 707. That's at 4.3 kilohertz. Then I'm going to increase it. I go big and I come back down again until I get 707 on the other side. Somewhere around in there. And I'm looking at close to 5,000. So my bandwidth here, as I'm guesstimating, is about 700 hertz. We calculated at about 330, so I'm getting twice as much as the bandwidth as I should get. But we're just doing this experimentally, so this is how you would set that up as far as looking for the bandwidth. So pretty straightforward. You've got some detailed instructions on here that tell you how to do this procedure. So you're going to do this procedure. You're going to ask some good questions. You're going to go through here. You'll encounter some new equations, but none of these are very difficult. You should be able to do all these type of things. Talks about tuning the circuit, talks about finding the resonant circuit, and then we're going to measure the voltage of the C and the voltage at the L across each of those components, and this should be at resonance. So you're going to tune into your maximum output again, and when you get there, your voltage on your cap and your inductor should be very close to each other. And then I've got some questions here in the back that I need you guys to take a look at and finish those up. So that's pretty much the lab that we're going to do for today. So the instructions are laid out. Your lab instructor will answer some of your questions, and I probably will give you, you may have to turn in a sheet for me just so I can take a look and see how you did. So any questions we'll take care of next week, and I'll see you then.